You already have some experience with this with grade 11 pre-cal because this was first introduced to you. So it's somewhat kind of like a recap of grade 11, and if you've never taken grade 11 pre-cal, this is something that you have to know. So in this particular case, we're looking at the special angles, and then we're probably thinking, what's so special about them? So, or what are they to begin with? So the special angles that we're going to take a look at are the 45-degree angle, 30 degrees, and 60 degrees. These are our special angles. And then we're trying to figure out the trig ratio, sine, cosine, tangent of these angles, but they want the exact value. Like, how can we figure out the sine, cosine, and tangent that's exact, right? So we'll see. So determine the exact value of a trigonometric ratio means that you must determine the ratios without using the calculator. And these ones have to be memorized. They have to be memorized now. Okay? We can determine the values of 6 trigonometric ratios by working our knowledge of a right triangle and the Pythagorean theorem. So I'm going to show you this, and I think I've shown this to the students when they were in grade 11, and how this is. Yeah. So if we have any triangle, okay, a 45-degree angle in here, and we know that this is going to be a unit circle. A unit circle is a circle that has a center at 0, 0, and the radius is 1. I think we discussed that yesterday, right? And the day even before. So if this is 1, we're trying to figure out, well, what's the x and what's the y? Okay, what would that be? So because if this is a 45-degree angle, that means the x is equal to the y. Right? You okay with that? It's called a right isosceles triangle. This x is equals to y in this case. So, well, how do we do that? I'm going to do this on a separate sheet of paper. So we know in from previous lesson, it's x squared plus y squared equals to r squared. That's the circle, equation of a circle. Now, we also know, and that's kind of look like a Pythagorean theorem when we look at that. In this case, x squared plus y squared, the radius in a unit circle is 1, so 1 squared is 1. We have to figure out what x and y's are. But what we already know, we know that if it's a 45-degree angle, x has to equal to y. Okay, so that means x is equal to y. So if you bring it over here, it's x squared plus, instead of y squared, it's going to be another x squared equals to 1. So that's going to give us x squared plus x squared equal to 1. Well, let's collect like terms. 2x squared equals to 1. Divide by 2. Divide by 2. So x squared equals to 1/2. Well, we don't want x squared, we want the x. So we have to take the square root. So x is the square root of 1/2. Well, we're not going to leave it like that. Remember, we want an exact value. So it's going to be square root of 1 is 1, and square root of 2 is 2. Okay, so x is equals to 1 divided by x squared. 1 divided by x squared. Now what we're going to do is we are going to rationalize the denominator. And you've heard of that term before, rationalizing the denominator, meaning we don't want an irrational number in the denominator. And how do we do that? Basically, as simple as multiplying by 1. Okay, I was like, well, it can't be that simple. We multiply by 1, but this is a special 1. And this is what it is. We're going to multiply by 1 in the form of root 2 over 2. Right? Does everybody agree that root 2 divided by root 2 is equal to 1? Let's simplify that. So that's root 2 times 1 is root 2. Root 2 times root 2 is root of 4, and root of 4 is 2. So if x is going to be equal to square root of 2 over 2. Okay, so we figured out x, but again, we said x is equals to y, right? So that means if x is root of 2 over 2, then y also must be root 2 over 2. Okay, is that okay? Not everything is logical there. So, in this particular case, if I put it in this form, this is going to be the x is root 2 over 2, the y is root 2 over 2, so that means this particular point has a coordinate root 2 over 2, root 2 over 2. Is that okay? Now we go over here. This is the reference angle of 45 degrees. So in quadrant 2, what would be that particular point? It's going to be negative x, positive y, right? So negative x, what would that be, negative x? It's going to be negative root 2 over 2, comma, positive root 2 over 2. Okay. In quadrant 3, what would that particular point? So this is still 45 degree, and that's our reference angle. What's the coordinate of this particular point there? It's going to be
negative root 2 over 2.
Uh-huh.
And then comma negative root 2 over 2.
Correct. So it's going to be negative root 2 over 2, comma, negative root 2 over 2. Okay. It's negative x, negative y. And last but not the least, so what would this be?
Root 2 over 2.
Root 2 over 2, comma,
Negative root 2.
negative root 2 over 2. Perfect. Okay, what did we just figure out? We figured out the x coordinate and then the y coordinate. But yesterday when we talked about this, the x is what? We also said that, okay, this is the cos of 45. Cos of theta is the x from yesterday's discussion. And then this one would be the y. Y is the sine of the theta, which is sine of 45. Okay? How would this be? What angle would this be? It's not 45 degrees anymore. What's theta over here? This is going to be cos of 135 and sine of 135. And how did we get 135? Or how did I get 135?
180.
Yeah, this angle in here in standard position really is cos of 135. Okay, now pull out your calculator. Okay, pull out your calculator. Okay, can you please figure out what's root 2 over 2 approximately? We'll do the same. 0.707, right? Okay, you're gonna see this number quite a bit. Yeah, that's right. Okay, so type in cos of 45. Okay, cos of 45. I'll do the same thing. Root 2 over 2 is 0.707. What's a sine of 45? Same thing. Okay, good, good, good. Now let's take a look. What's cos of 135? I'll do the same thing. Cos of 135. It better be a negative number because it says here negative. Okay, it's going to be negative 0.707. Is that kind of amazing? So we figured out the exact, very exact value, and then this one that shows on your calculator, that's the approximate value. Okay, now do one more thing. Can you go sine of 135? Good, very nice. What do you think this is? What angle would this be? Cos of what angle? 225. How did we get 225? Okay, 180 plus 45, right? And then this one would be the sine of 225. Oh, that's you. Now, let's go back to our calculator. Let's kind of verify this. Cos of 225, what would that be? Did you get a negative 0.07? Yeah? Okay. So, good. Next one. What would this be? Cos of 360 minus 45, 315. Is that? Okay. Oh. And then the y is the sine of 315 degrees. Okay, nice. Is everybody okay? Yeah? So this is kind of neat, right? We figured out the very exact value based on what we already know from previously. Now, when you were writing a test, when you were writing this test, I was kind of playing around with numbers. You don't have to write this down, but I'm just going to show you that it works, okay? Don't write this down because I want to show you that no matter what it is, we're going to end up with that, okay? And there's nothing to worry about. Okay, I'm going to create a different one. I'm going to create a right triangle, but from the point 3, 3. So I'm not using, okay, so if I draw a triangle right there, 3, 3. So that's a 45 degrees here. You know, that's 45 degrees here. What's R? Is R 1? What's R gonna be? Okay, so like I said, you don't have to write this down. I just want to show to you that it works every time. So R is the square root of x squared plus y squared, and we figured that out, square root of 18. And then we can actually simplify the square root of 18 by taking square root of 9, square root of 3. That's 3 root of 3, right? Yes? Yeah.
Can you 2.
Oh, 2, yes, thank you. Okay, thank you. Glad you're at the front. So the radius is 3 root of 2. Now, I'm gonna ask you this. What's cos of 45 degrees based on this picture? Our x is adjacent is 3, opposite or y is 3. So cos of 45 would be adjacent over hypotenuse, yes? 3 root of 2. Okay, well that doesn't look the same, but wait a second. If I cancel this, I cancel that, that's just 1. And that's going to be 1 over root of 2. And then rationalize it. You're going to get root 2 over 2.
That's weird.
And isn't that amazingly weird? Amazingly weird. It doesn't matter how big our triangle is. It could be this. It could be this. The ratios are always the same. The ratio between opposite and hypotenuse doesn't change as long as we keep that 45-degree angle there. Right? Mind-blowing. That's why sometimes I get excited about these. And right? Good? Okay. That's for that. I'm gonna please put down memorize. Now, this is my strategy. I don't want you to memorize every single one. The strategy is to memorize quadrant 1, because once you know what quadrant 1 looks like, you can just do the reflection on quadrants 2, 3, and 4. Okay? Yeah, it's pretty neat, isn't it? Yeah, I don't know about you, but for me, I'm like very excited inside. Now, before I go to 30 degrees, I'm going to skip this one here. Okay, I'm going to go to page 12. I'm going to go to 60. Okay, and I'm going to show you why I choose 60. Okay, again, I'm going to write some numbers in here. Again, these are exact values, but then you're not going to ask anymore, how did you get that values, because you're going to know in a few minutes. Okay, so this is what I'm going to tell you first. Okay, so if this is 60 degrees, I can recreate a triangle from here. Okay, I'm going to come back to this. Suppose you have an equilateral triangle. What does an equilateral triangle look like? Equilateral triangle means all 3 sides are equal. Okay, if all 3 sides of the triangle are equal, what about their angles? They're all equal. Well, how big are those angles? 60 degrees. Okay, this is in our previous life we learned this, that the sum of all the angles in a triangle is 180. Well, if they're all the same angle, then it's going to be 180 divided by 3, so it's going to be 60, 60, 60. Okay, so here's what we're going to do. Well, I don't want that kind of triangle. I'm going to cut this in half. Cut that in half. Okay, so that means, what angle is this? This is 30. Right, so that's now, because this is an equilateral triangle, what I'm going to do is I'm going to say this is 1, this is 1, and this is 1. But if I cut it in half, how big is this piece? A half, right? Because we started off with isosceles triangle 1, 1, 1, I'm going to cut it in half, so that means this is 1/2 and then this is the other half, right? Okay, so what I'm going to do is I'm going to erase this thing because I don't need this. Actually, just going to work with this part in here. Let's show you something that we're going somewhere, okay? You just got to be very patient with me. Can you see that this is kind of starting to look like that? Okay, what do you think the x is? 1/2. So this is where 1/2 is. So that one is easy, but we don't know what the y is. Okay, well, we don't know what the y. So how can we figure out the y? X squared plus y squared equals to r squared. Okay, we know that 1/2 for x, 1/2 squared plus y squared equals to, our radius is 1 squared. That's good. Huh?
You subtract x squared.
Yes, okay. Every time you say something, it's like, did I make a mistake? Okay, no, you're just a few steps ahead of me. So this is 1/4 plus y squared equals to 1. So yeah, I gotta subtract 1/4 on each side. So y squared equals to 1 minus 1/4. And you know me by now, I like to show my work. So 4/4 minus 1/4 equals to, oh, I forgot the square, 3/4. Yes? Right? So y is equals to the square root of 3 over 2. Right? Because we have to take the square root of this, square root of left side, square root of the right side. Square root of 3, that's an irrational number. Leave it as square root of 3 because we want the exact. But then the square root of 4, we know it's 2, so it's just 2. So, what does the x? So therefore x is 1/2. And what's the y? Root 3 over 2. Okay, so 1/2. And then the other one would be root 3 over 2. Now we're going to put that over here. So the coordinate is 1/2, comma, root 3 over 2. That is working in quadrant 1. Okay? Okay, help me out. Go type in on your calculator. Okay, well, before you do that, what's the function for that will give you 1/2? Cos of 60 degrees, right? So the x is the cos of theta, and theta is 60 degrees. And then the y is the sine of 60. So let's do that. Let's see if we're getting the right number. Cos of 60, 5, right? Which is 1/2. So that one works. Go, let's do sine of 60. Okay, did you get 0.866 approximately? Well, what's 0.866? If we do root 3 divided by 2, and that's 0.866. Yeah. Okay, so the x and y coordinate. Okay. What do you now that we have that experience from that 45 degrees, what would this be? Negative 1/2, okay, because it's a negative x. And what's the y? Positive root 3 over 2. Okay. Our reference angle here is 60 degrees. What's theta? What's the angle in standard position? 180 minus 60, so it's 120. Okay, let's do that. Okay, let's try it. Okay, let's see. This makes sense to us. I'm gonna try cos of 120. Okay, cos of 120, we can do the same thing. Did you get negative 0.5? Yeah, okay, good. And then if we do the sine of 120, we're gonna get a positive 0.866 again. Okay, let's finish this off. What would this be? This is gonna be negative 1/2, comma, negative root 3 over 2. Right? They're both negative because it's left and then down. What would this be? Cos of 240. Thank you. And this one would be the sine of 240. Okay, we don't have to do this on our calculator. We know it works. And last but not the least, in quadrant 4, this is going to be positive 1/2. And then negative root 3 over 2. And then this 1/2, that would be the cos of 300. Yeah, because it's 60 degrees. 360 minus 60 is 300. And then this one would be the sine of 300. Yes? Good. Okay. So now, that works for this. I'm going to go back and do the 30 degrees. What do you think the 30 degrees would look like? 30 degrees would be, if this is 60 and this is 30, so it's like this one, but can you imagine this? Like taking this triangle and then turning it to the side and then sticking it over here. So what's the x? Root 3 over 2. And what's the y? 1/2. And then we could actually visualize this, because if it's 30 degrees is somewhere over here, right? This is 0, this is 90. So 30 degrees would be a third of that in quadrant 1. And it's a halfway of the radius. Right? So we got the visual part of that. And then root 3 over 2, that's, we know it's going to be 0.866, slightly bigger. So what's the coordinate here? This is going to be root 3 over 2, comma 1/2, both positive. So this is going to be the cos of 30 degrees and sine of 30 degrees. Okay. This one would be, so negative root 3 over 2, comma 1/2. Okay. The reference angle is 30. So that means, what is this angle here? 150. So that's going to be cos of 150, sine of 150. This one, it's going to be negative root 3 over 2, negative 1/2. That makes it cos of 180 plus 30, 210. Thank you. And then sine of 210. And then last but not the least, the space over here, this is going to be positive root 3 over 2 and a negative 1/2. And this one is going to be cos, the angle in standard position would be cos of 330. Thank you. And sine of 330. Okay. So these numbers have to be memorized. So we did all that, but it's actually at the back. Okay. So the very, 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 very back of your booklet, like last page. Okay, so disregard the other parts yet. We haven't talked about the radian mode yet. We're still focusing on degrees. So 30 degrees, root 3 over 2, and then a half. 45 degrees is root 2 over 2, root 2 over 2. And then 60 degrees is over here. If you actually create your circle, and you say, okay, where's my 30 degrees? My 30 degrees is like somewhere right there. Okay. So you know that this is going to be approximately a half up, because if this is a radius of 1, then you know this is going to be a half. I didn't do a good job in the circle, but, and then this one is root 3 over 2. Okay. Now if it's 60 degrees would be up here. Okay. So you know the x is a half. X is a half, and then the other one's root 3 over 2. A half, because if this is 1, this is halfway. You see that? So it's not bad memorizing these things. And you only know one, and then the rest could be just a reflections. Okay, so those are our special angles, and then now we're going to do the exact values for quadrantal angles. So what would this be? This one would be, if x is 1, what is y? Y has to be 0, right? So that means this is cos of 0 degrees and then sine of 0 degrees, or 360. Right? Cos of x is cos of theta is x, sine of theta is y. What would this be? What's the coordinate point here? Huh? 0, 1, right? And then this is your x, and then this is your y. What would this be? Cos of 90, sine of 90. Next one. What's this one? Negative 1, 0. Thank you. Negative 1, 0. So that's going to be a cos of 180, sine of 180. And then last but not the least, 0, negative 1. This is the cos of 270 degrees, and then this is the sine of 270 degrees. Okay, now just for the fun of it, okay, help me out. Can you type in sine of 180? Sine of 180 on your calculator and see what number you get. 0. And then we could actually see that in here. Okay, because visually the sine of 180 is in a unit circle. If this is a unit circle, the circle it rotates, the angle is 180 degrees, and you're on the x-axis, so that means there's no y value. Okay, good. Now let's take a look at this. Determine the exact values of the 6 trigonometric ratios. Oh, okay. Now, no one had asked about this one yet. So this is fine. These are all sine and cos. Well, what about the tan? Can we figure out the tan? What's tangent again? Sine divided by cos. So once we have cos and the sine, right, we can figure out the tan by taking the sine divided by the cos of the theta. Okay. Let's try some. We're probably going to go as far as example, a little bit of example 1. I'm probably stopping here, if that's okay. It's been a long day. You've written your test and then you're writing some notes. Okay, now let's see here. We're not going to look at our stuff, okay, because we already wrote everything down. Determine the exact values of 6 trigonometric ratio. So what we're going to do is we're going to go cos of 120, sine of 120, tan of 120. That's what they meant by 6 trigonometric ratio. What did I say? Where am I? Secant 120, cosecant of 120, and then the cotangent of 120. This is what we want, but the exact values. Okay, it's easy to just type this in onto our calculator, right? It's like, oh, that's my number. Okay, so let's see. Here's a visual. They want exact. Well, in our circle, unit circle, where would the 120 degrees be? So it's going to be in somewhere in quadrant 2, and it's going to be right here. Right? Okay. This is 120 degrees. What's our reference angle here? 60. Thank you. 60 degrees. Okay. So this is, you're not going to memorize this piece, but what you're going to do is you're going to memorize the angle over here. Remember that? Okay, so this is, instead of over here, I'm going to go 60 over there. Okay. Now, if it's 60, what would this be? What's the x? X is a half. The y is √3 over 2. So that means the cos is a half, because cos of the angle is the x, and then the sine of the angle is √3 over 2. That's the y. Yes, we'll get to that one. So, a half, and now, because we're in quadrant number 2, it's on the other side, so it's going to be negative a half. Negative a half. Okay? Now, what about tan of 120? Tan of 120 is sine 120 over cos of 120. Okay, well, let's take a look. Sine is √3 over 2 divided by negative 1/2. It's the same thing as √3 over 2 times the reciprocal, so 2 over negative 1. So it's going to be negative √3. Okay, negative √3. Now that we have that, now that we have this, I think it's going to be easy to do these last three, because secant theta is the reciprocal of cos. Reciprocal, what does that mean? You know, like whatever in the denominator and the numerator are, they switch places. So this is still going to be negative, but it's going to be negative 2 over 1 or negative 2. Cosecant would be, it's going to be 2 over root of 3. And then the cotangent would be negative 1 over root of 3. Okay. Actually, I think I'm just going to stop right there. Tomorrow I'll finish up this last piece. Let's see if we have everything. Okay, now before I wrap this up, I want to point this out that, you remember the cast? Okay, I'm going to do that up here maybe. So cast, what does that mean again? Here, only the cos is positive in quadrant 4. All are positive. Sine is positive. Tan is positive. The rest are negative. So, which quadrant are we? Quadrant 2. So that means only the sine is positive. Only the sine is positive. That's true. It works, right? Only the sine is positive. The cos is negative. The tan is negative. And then you're probably thinking, well, what about cosecant? It's positive. Obviously, it's going to be positive because the only thing that we had to do was to reciprocate the number, right? So it's not violating any rules that we've already talked about from way back. So that's quite amazing. I hope you're just as excited as I am in the inside. And so I think, yeah, I'm going to stop right there. Tomorrow we'll pick up all of these, and if you do want to try these things at home, you can try it. And yeah, we'll pick it up tomorrow. Okay? Have a good evening, and before you go, I want to make sure that everyone is keeping up with the assignment. Okay, practice, like the best place to get a lot of practice and exposure and things like that. Okay. Other than that, have a good evening. I'll